Hi, this is Philip Powers with my Managed Machine Learning Projects presentation for the class. We all know the assignment. I won't spend much time there, but we do need to include all of the things that are looked for in the project. Um, for the overview, we have the opportunity evaluation, CRISP-DM, validation plan, our design, and our risk. For going through opportunities, the one that we chose is a real estate uh, guided model for property values of real estate on the market. Uh, we asked the three questions. There is definitely a problem to be fixed. Um, Machine learning definitely can help solve this with the features. And does someone care? Yes. As a fledgling landlord, I can tell you there are definitely people that can use this product that do not have access to expensive tools or tools that larger organizations have. There are a lot of features that can be chosen for this, and I've gone through the exercise of giving some examples of what we think would be from heuristics, what we think would be important features to be included. And down the road, uh, more complex iterations, there are other things that we can look at as well. Using CRISP-DM on this very high level, very quickly, um, we'll go through business understanding first. We define the problem. We define success and identify factors here. I listed all the information of that to make sure that we definitely understand what we're trying to understand. It is defined. Data understanding, this is a little tougher case. A lot of work will need to be put in because the data will come from different sources, won't necessarily come from APIs. It come from public information that could be given in a lot of different formats that have to be um, put into numbers, and they have to be reliable numbers that are compatible with the model. Data preparation, also we've got to make sure the data coming in is good and is usable and gives accurate results. A lot of work on that end. The modeling for this does need to be supervised. We do have access to historical information. We also have heuristics on this. So simple linear regression is the direction that we need to go. Using mean absolute error is the correct algorithm for this case. Um, Outliers are going to be something interesting to deal with because outliers can be important to us in spotting opportunity on some of the fields in this case. An example, sales price or property size. Um, the deployment in this case um, would be a scheduled rollout that would be of data that would take over months. Um, we'll need to evaluate performance as we go, as this would be a new model, and a lot of iterations would need to take place. Um, for evaluation, um, for validation, this is very tricky because we'll be training this in a QA environment, most likely. And in doing that, the batch timings, data conditioning could all be different than reality once it goes into production. So that would be something to keep a very close eye on, especially if this is purchased by a company and used on a larger scale. There's a lot more risk that we have to keep an eye on there. So for the system design, for the interface initially, instead of a dashboard, would likely be a very simple Excel output that would utilize as much graphics as possible to help the user visualize these as we're learning to read the results of this data, not simply using a spreadsheet. But over time, it would need to go to perhaps a dashboard view that could help with some alerts and things like that that would be very useful. Supervised learning, again, is what's selected, would be run offline using simple linear regression. Uh, this would possibly be sold to a small business. This would possibly be sold to a larger business later And a lot of what we do here would be in matching with their architecture, but I could see this being a cloud language. I believe the smart way to start this would be in Python, but would need to adjust to any system that a company is using. As an example, if they're using JavaScript, obviously it would need to be adapted to what's compatible with their architecture. Um, After using this model, as I may have mentioned earlier, one possible continuation of this would be to use this with other models. For example, they show rental income, they show expenses as they could correlate to age of the home or things of that nature. A lot of risk in this one because of the essentially because it is new and because of the data. The data is going to need a lot of management decisions over time to perhaps replace or update data sources where perhaps an API becomes available or other sources are deemed to be better than what we first identified. Um, and for that reason, versioning would need to be tightly controlled because we need to know what worked and didn't work specifically, and we could accidentally replace something very easily with something less effective. We're going into production. We could probably go live initially, but using a champion challenger approach, once we're really using the information, just so that we don't accidentally replace a very valuable model with one that could be less effective, is something to be very careful of, that we will need to analyze a model before we replace it as the champion model. Thank you for your time.